So the first thing you need to know about circular trigonometry is where it comes from. And it comes from the unit circle, literally the unit. And what that means is if we take an X and Y plane and we zoom in to just the first box, going up and down and left and right, trying to make this like as close to scale as possible without graph paper. And I have my center at the origin. This right here represents the unit circle, and all trig lives in this bubble. Okay, now the x-axis is here, and the y-axis is here. And basically what we do is all trig lives within this space. All right, so a couple things you need to know. We use the unit circle a lot. The unit circle helps us determine our sine and cosine and tangent. And that's going to come in a later lesson. We're not going to do that today, but this is something that helps us to do with coordinates. So as soon as you're out of triangles and in coordinates, this is where this is going to help us. This coordinate where 1 is, this is actually 1, 0. Up top, this is 0, 1. That's the value at coordinate for this one. Down here on the left, this is -1, 0. And at the bottom, this is 0, -1. So these are the 4 coordinates that we use to help us determine sine, cosine, and tangent with coordinates. What this diagram also does for us is it helps us set up all of the angle measurements when we have to draw them. So what we're going to do is we're going to draw some basic angles on the coordinate plane using what we consider unit circle measures. And how we split it up is basically how up here, just so you know, the top right is quadrant 1. So we're going to label that. This is a quadrant 1. Top left is quadrant 2. Bottom left is quadrant 3. And bottom right is quadrant 4. So we're going to be able to tell where to put our angles based on what quadrant they're in, based on how big they are. Okay, so a lot of times trig will ask us like, what quadrant is the angle in? And you'll be able to tell based on where it stops. Okay, the next thing is, where do we begin drawing? So in trig, for the circular trig unit, all graphs for angles start at 0 degrees, and that is located on the x-axis to the right. Okay, so when we draw our angles, we don't need a big one to do it. When we draw them, there's our x, there's our y, this is our coordinate plane. 0 is always here. 0 degrees, always here on this side. Okay, and then the second thing that you need to know is that the angles always open up counterclockwise. So standard angles open counterclockwise. So what that means is 0 is standard and it stays here. This is our terminal ray. This means that, or I'm sorry, our initial ray. In an angle, this is like the beginning part of our angle. It always starts at 0. And then depending on how big it is, we crank it open. So it's going to be like, this is base, and then this could be 10 degrees, this could be 30 degrees, this could be 80 degrees, this is 90 degrees. So basically it opens up counterclockwise. So if I'm looking for a 30-degree angle, I would crank it open about 30 degrees, and from the origin, there would be my terminal ray. So initial starts at 0, and this would be 30 degrees, and this is how I would draw a 30-degree angle on a coordinate plane. Okay? Now, obviously, it's not drawn to scale, but that's how it goes. So if I wanted to open it up full to like where the y-axis is, what would happen is that I would be cranking it open a full 90 degrees, because from 0 being here and this being perpendicular, the y-axis up would be a 90-degree angle from my 0. So I want to draw a small one of these so I can show you. Here's my x, here's my y. X is my 0 degrees, and if I wanted to crank it open all the way to the y-axis here, this is a 90-degree angle. And because it's located on the y-axis, that's called a quadrantal angle. It's quadrantal because it's not in the quadrant, it's literally on an axis. Okay, so 90 is a quadrantal angle. The next one would be if I wanted to crank from here all the way up, open it all the way up to the other side. And if I do that from here all the way to here, this is a 180-degree angle, also quadrantal, because you start at 0 and you're cranking it open, like opening it up like a book all the way. It goes all the way open, like a straight line. And that's pretty much where we ended it with what you know about geometry. But since it's circular, this thing goes all the way around. So our third one is if we take another 90, we can take this and open it. Keep going, keep going, keep going, and stop here. We've gone 90 plus 90 plus 90. This would be 270 degrees, which is another quadrantal angle, and it's the y-axis pointing down. So that's 270 degrees, which is 3/4 of a rotation. And then, of course, if you take this thing and you go full circle all the way around, there's 90, there's 180, there's 270, and then you keep going and you finish, that is when you have a 360-degree angle. And all of these angles that I just wrote down, 0, 90, 180, 270, 360, are called quadrantal angles because they live on the x-axis or y-axis. Now what we're going to do is we're going to take this diagram and we're going to put it together with this diagram, because what we need to know now is how all this works. So, recap real fast. I think I need one more line here. I want to make it nice and pretty. Pull this down so you can actually read it. It's so weird. There we go. All right. So as you're looking at this, here's X, here's Y. We always start on X on the right, always. Okay? At 1, 0, we're at 0 degrees. We're going to move counterclockwise because that's how we move standard angles, counterclockwise. We're going to stop right here. At right here is 0, 1, and that is 90 degrees. Then we're going to continue counterclockwise. We're going to hit here, which is at -1, 0, and that is 180 degrees. And keep going down. We're going to hit this one down here, and down here is 0, -1. That's 270 degrees. And when we click back all the way around, we have hit a full 360. So this is called a full rotation or revolution. around the unit circle. Starts here. Watch, this is going to look like a football. Oh, it doesn't look too bad, actually. Boom. So you need to know the coordinates because they're one out in each direction, literally 1 unit big for a radius. And here are the coordinates that go with those measurements. And these are the quadrantal angles in degrees that match those positions. So those are the first things that are super, super important for you to make sure you know.